Dear students, under the series of lecture on the topic graph theory, here we have lecture 4. Previously in lecture 3, we learned the first fundamental theorem of graph theory. Now here we have the corollary of the first fundamental theorem. The corollary says that in any graph G, the number of vertices of odd degree is even. So if we consider a graph G and if we consider the vertices which have only the odd degree, then the number of vertices of odd degree will be even. So let us prove this corollary. Before proving this corollary theoretically, let us see the illustration of this corollary with the help of few graphs. So here first we consider this simple graph. Let me take the vertices of this graph as V1, V2, V3, V4 and V5. Now since we are concerned about the degree of this graph, let us mark the degree of each vertices. What is the degree of V1? The degree of V1 is 1, 2. What about the degree of V2? It is 1, 2, 3. The degree of V3 is also 3. The degree of V5 is 2. And the degree of V4 is 2. We want the vertices of odd degree. So what are the vertices with odd degree? This is even because it is 2. This is 3. So this is an odd degree vertex. So this is also an odd degree vertex. Whereas these two are even degree vertices. So now we are concerned about the odd degree vertices. So vertices of odd degree. Vertices of odd degree. So what will be this set? What are the vertices of odd degree? V2 and V3. So let us put them as a set. So V2 and V3. These are the two vertices with odd degree. So therefore the number of vertices of odd degree will be, so number of vertices of odd degree will be equal to 2. We see that the number of vertices of odd degree is even number. Since it is 2, it is an even number. That is what we want to prove in this corollary. In any graph G, the number of vertices of odd degree is even. To understand this more better, we will consider one more example. Now here we have another example, and let the vertices of this graph be V1, V2, V3, V4 and V5. And here we have V6. Now we shall write the degree of each vertices. What is the degree of V1? We have 1, 2. So the degree of V1 is 2. What about the degree of V2? It is 1, 2, 3. So this is 3. Degree of V3 is 1, 2, 3, 4, 5. So this is 5. What about degree of V4? 1, 2, 3. Degree of V5 is 1, 2, 3. And degree of V6 is 2. We shall now write the vertices of odd degree and we will form a set. So here the degree is 2. So we will not write in that. The odd degree vertex is V2 because its degree is 3, which is an odd number. Then V3 because its degree is 5, which is also an odd number. And what about this? The degree is 3. It's an odd number. So V4. It's an odd degree vertex. V5 is also an odd degree vertex. Whereas V6 is even degree vertex. So we shall not put in that set. So these are the vertices which have odd degree in this graph. So how many vertices are there? 1, 2, 3, 4. So there are 4 vertices. So therefore the number of vertices of odd degree is equal to, number of vertices of odd degree is equal to 4. 4 is what? It is an even number. So therefore we have proved in this graph also that the number of vertices of odd degree is even, since we got 4 over here, which is an even number. Now this is through illustration we have proved this corollary. Now we will see the actual theoretical proof of this corollary. So now we shall write the proof of this theorem. First we shall always remember we have to consider the graph. So let G of v comma e be a graph. So first step is we have to consider a graph. And now since we are dealing with degree, and that too in particular odd degree, so we shall divide the vertices of this graph as odd degree vertices and even degree vertices. That is, we are going to divide it as two different subsets. So now what are we going to do? Let us divide the vertex set. So we are going to divide the vertex set. So let it be capital V. Okay, we are going to divide this vertex set into two subsets. What are they? So first we will have subset V1. V1 will be the set of vertices of odd degree. So all those vertices with odd degree will come into the set V1. And then V2 is the set of vertices of even degree. So all the even degree vertices will come into the set V2. So we are categorizing, we are splitting this V as V1 and then V2, two different set. So here we have all the set of vertices of this graph G. So we are taking that and we are splitting it as two sets. How are we splitting? V1 as odd degree vertices and V2 as even degree vertices. So after splitting up, we are going to write the statement of the first fundamental theorem of graph theory. That is, we are going to apply that theorem over here. For that, we should write the statement of this theorem. So what is this first fundamental theorem of graph theory? The sum of the degrees of the vertices of a graph G is twice the number of edges. So by this theorem, we know that summation over I degree of Vi is equal to 2q, where q is the number of edges. So if you sum up all the degree of the vertices of G, it will be equal to 2q. This is by the first fundamental theorem. So this theorem has to be stated here. So we have taken and written the first fundamental theorem, that is summation over Vi element of capital V, that is for every vertex in capital V. If you sum up the degree, it is equal to 2q. Now from this we observe that the sum of all the degrees of the vertices is equal to an even number, because whatever is the number of edges, whatever the value q takes, if it gets multiplied with 2, obviously it will become an even number, isn't it? So because 2q is always a even number, so this is an even number. Therefore we see that summation Vi element of capital V degree of Vi is equal to an even number. So that we have taken and written. Now this is the whole set capital V. But in this corollary, while proving this corollary, what did we do? We have splitted up this set V as what? V1 and V2. That is, all those vertices with odd degree and all those vertices with even degree. We have split up the set capital V as V1, V2. So the summation can also be splitted up now. How can it be splitted? All those vertices of V1 degree of Vi plus summation all those vertices from V2. So from V1 and V2 and degree of Vi is equal to, what is the right hand side? It is an even number. So if you see here, we have splitted up the set V as V1 and V2 and we have got these two summation. Now we are concerned about this one. What about this summation Vi element of V2 degree of Vi? What will be this sum? We know that V2 is the set of all those vertices with even degree. So if you add up all the even numbers, you will get an even number only. So this is an even number. So obviously, because all the degree are even, so if you add up all the even numbers, the resulting answer will also be an even number. For example, if you add 2, 4 plus 6, it's equal to 12. You can see that all the numbers are even. So whenever you add up all the even numbers, you will result in an even number only. So that is an obvious knowledge from number theory. So that is what this is an even number. So if this is an even number, then here also you have an even number, here also you have an even number. So when you take it to the other side, it will be an even number minus an even number, which will again be an even number only, which will imply that this is also an even number. So this implies summation vi, element of v1, degree of vi is equal to an even number. That is, if you sum up all the degrees of vertices with odd degree, you will result with an even number. Now, since each term in this summation is an odd number, because we are considering only odd degree vertices, so v1 will be of odd degree, another number, for example v2, will be of odd degree. So each term in this left hand side will be an odd number, and this will be meaningful only when v1 has even number of vertices, because degree also odd and number of vertices also odd means this fully will become odd number, and it will contradict this one, because we have found that this as a whole is an even number. So it becomes a contradiction in that case. Therefore the number of elements of v1 should be odd only. Even only. So the number of elements of v1 should be even only. For example, if you have the degree as 3 plus some degree as 5, because odd degree vertices only we are considering, plus degree as 1. If you add up, you can see that we result with an odd number. So 5, 6, 7, 8, 9, because only 3 numbers we have taken. Whereas if you have it as 5 plus 3 plus 1 plus some 9. Now what is the case? It is 15, 16, 17, 18. So the number of vertices will be 18 in this case. So, but how many numbers we took? The total degree will be 18. The number of vertices that chosen will be 1, 2, 3, 4. But if you have even odd number of vertices, you will result in an odd number, which is a contradicting fact. Therefore, the elements of V, the number of elements of V1 should be an even number only. So, I will write that in words here. You will understand it. So I have written here, since each term in the summation on the left hand side is an odd number, because they are odd degree vertices, it will be meaningful only when the number of vertices is even. Because if you have odd degree and even number of vertices only, you will get an even number. For that reason only, we are saying that it will be meaningful only when v1 has an even number of elements. Hence we have proved that number of vertices of odd degree, because v1 is number of vertices of odd degree, like that only we chose. So number of vertices of odd degree in a graph G is always even. So hence we have proved the corollary. So I hope you would have understood this corollary and how to prove this. And this is the illustration. So if you see here, the number of vertices is 2. Okay, so therefore, but we can see that v2 and v3 have odd degree, and therefore the number of vertices of odd degree is 2. So here also all these vertices have odd degree, and if you see the number of vertices is 4, which is an even number. So that is what we have proved. Kindly follow the upcoming video lecture on cubic graphs, where we will be solving a very significant theorem which says that every cubic graph has an even number of vertices. So kindly follow the video lecture for more topics on graph theory. Thank you.